Hello and welcome back to our flipped classroom. Today we're talking about units and measurement. So we're going to jump right in and talk about kind of why we need units. Obviously, when we're measuring, we want to be able to communicate clearly what we've measured. And as you can see from our little cartoon here, it's important that we have a standard unit of measurement. Otherwise, we're all going to be working from a different standard and we're not going to be able to communicate clearly. So there's a classic example of this. This is the Mars Climate Orbiter. It was a $125 million NASA project. And in 1999, it entered Mars' atmosphere, and it was 100 kilometers lower than it was planned to be, and it was destroyed by the heat. And the reason that it entered Mars' atmosphere so much lower than it was planned was because scientists in two different locations were working on the thrusters that slowed its entry. And one set of scientists was working in pounds, or the US customary system, and one set of scientists was working in newtons, or the metric system. 1 pound is not equal to 1 newton. 1 pound is almost 4.5 newtons. And so the thrusters did not have enough energy to slow the descent of the orbiter, and we lost $125 million spacecraft and about 10 years of work. At the time, one of the lead engineers said, "This is going to be a cautionary tale that will be embedded into instruction into the metric system in elementary school, high school, and college science courses till the end of time." And he was pretty close. Here we are 22 years later, and we're still talking about this failure because it's really, really important that we communicate clearly when we're working with measurements. So what are our standards? So when we measure, we capture some dimension of an object that we're measuring, and we compare it to a standard. If we think about the US customary system, we have this unit called a foot. The standard for length used to be the king's foot. Are there problems with that? Of course. Every time you have a new king, you have a whole new set of measurements. What if the king's young and he's still growing? Do we keep changing the measurements every year? So we want to have a standardized system. So we're going to talk about our 3 systems. And those 3 systems, we have 3 main systems. The one we will use most commonly in this course in chemistry is the metric system. And this is the one with the base 10 and all of the prefixes. Very closely related to the metric system, and really the only difference is what the base unit is the Système International, which we'll call the SI system. And then, of course, the one that we use in our everyday lives is the US customary system. We used to call this the imperial system for Great Britain, but Great Britain doesn't use this system anymore. So it's become the US customary system. So anytime we take a measurement, we have a quantitative observation. Remember, quantitative means numerical, consisting of 2 parts. We have a number, and we have a unit, or it's something that tells us what the scale is. So for example, I might have 20 grams. So 20 is my number, grams is my unit. We might have a more complicated unit, like a joule times second. So we have 6.63 times 10 to the negative 34th joules seconds. So we have a number, a really, really tiny number in this case, and a unit. And this is a complicated unit. It's an extrapolated unit, so joule seconds. Okay, so let's talk about our systems. So let's start with Système International, the fundamental units of SI. So if we're measuring mass, the fundamental unit in SI is kilogram. The fundamental unit of length is the meter. The fundamental unit of time is the second. The fundamental unit of temperature is a Kelvin. And those are probably the ones that we use the most. Electric current is an ampere. the amount of substance we will use a lot in chemistry, and that's a mole. And then luminous intensity is a way of measuring light, is called a candela, and it really does come from candle. So those are our C7 International fundamental units. These are not the same as the metric fundamental units. You'll notice that when we look at the metric fundamental units, they are all the base units: grams, meters, seconds, liters. There are no prefixes on their fundamental units. They are the base units. Also, metric measures temperature in Celsius, not Kelvin, and volume in liters, not cubic meters. We'll use both. Very, very often we use metric. Okay, so one of the conveniences of the metric system is that it has these prefixes that make it very, very easy to convert from small units to large units. You don't have to memorize that there are 5,280 feet in a mile, because you know that a kilometer contains 1,000 meters simply from its prefix. So there are certain prefixes that I'm going to ask you guys to memorize. You have to know these prefixes. You have to be able to use them to convert, and we'll talk about conversion in a couple of days. So the first one that I'm going to ask you to know is kilo, abbreviated with a K, and there are 1,000 base units in a kilo unit. So there are 1,000 grams in a kilogram. There are 1,000 meters in a kilometer, and that's 10 to the third. You will also need to know centi, abbreviated with a C, and there are 1/100th base units in a centi unit, or 10 to the negative second. You will also need to know milli, abbreviated with a small m, and there are 10 to the negative third, or 1/1000th base units in that unit. There's micro, so this is abbreviated with this little, looks like a cursive U. It's actually a Greek letter mu, and there are 10 to the negative sixth base units in this unit. We'll also use nano, abbreviated with lowercase n, and they're 10 to the negative ninth. And we will use pico, and that's abbreviated with a P, and it's 10 to the negative 12th. So you notice that we have a lot of units, a lot of prefixes that I'm asking you to learn that take us from a base unit to a much smaller unit. And that's because in chemistry, we're always looking at the nanoscopic or the microscopic in order to explain the macroscopic. So we work with a lot of really, really small numbers. Okay, so using metric measurements. We'll talk about these in class. If we were to measure the distance from school to home, are we going to use meters? Are we going to use centimeters? What makes sense here? Probably something like a kilometer. If we're measuring a desk, maybe meters. But if we're measuring a germ, now we're looking at micrometers or micrometers. Diameter of an atom, now we're looking at picometers. So it's important that you understand what these prefixes mean so that we can kind of think about how large or small an object is and what would be the appropriate unit for it. Okay, so when we are talking about metric conversions, when we talk about the base unit, we're talking about the unit with no prefix. Okay, and if we want to convert in the metric system, all we have to do is move the decimal point. Base unit is the unit without a prefix. If we want to convert 18 liters to milliliters, we're going to start with our base unit. And then because we are moving towards a smaller unit, we're going to move our decimal place 1, 2, 3 times, and we're going to have 18,000 milliliters for 18 liters. Now, if you look at your notes, you'll see that the exponential notation for milli is 10 to the negative 3. This does not mean to multiply by 10 to the negative 3. Each milliliter is 10 to the negative third liters. So to convert from liters to milliliters, you're actually going to divide by 10 to the negative 3, which means you're multiplying by 10 to the positive 3. So that's why this number gets larger. Now, if we want to go the other way and we want to convert milligrams to grams, again, we're going to move the decimal place, but we're moving to the left 1, 2, 3 places, and we're going to have 0.45 grams. So a milligram is really small. If we are converting to grams, we expect to get a smaller number. All right, one last one. If we're converting 20 kilograms to milligrams, we have to move it 6 places. And so our 20 kilograms is going to give us 20 million milligrams. So there are 3 things primarily that we're going to be measuring in the chemistry class: length, volume, and mass. And you can see here that we have several different units for measuring, or several different instruments for measuring length, volume, and mass. Let's start out by talking about measuring volume. Very often with volume, we're going to be using a graduated cylinder. We may also use things like pipettes and burettes. So we'll talk about those when we come to them in the lab. But when we're measuring volume, we're always going to be reading the bottom of the meniscus. When we talk about the meniscus, we're talking about that curved surface of the liquid in that cylinder. So we're going to read the volume using all of our certain digits and one uncertain digit. So what do I mean by that? So the certain digits are the ones that we know because there are the graduation marks on the cylinder. And the uncertain digit is the reading that we estimate. It's going to be the last digit. So let's take a look at how we read. So here is, as I said earlier, the meniscus, okay? And that's the bottom of this curve of the liquid in the narrow cylindrical container. And we're always going to read volume from the bottom of the meniscus. And we're going to take a couple of steps to make sure that we are reading it correctly. We want to make sure that we are eye level with the meniscus. If we view it at an angle, it tends to lead to an error, and that error specifically is called a parallax error. If we view the meniscus from an angle, we are either going to read it too high or read it too low. So we want to make sure that we are eye level with the meniscus in order to read it properly. So when we're reading the meniscus, we're going to look at these graduations. We're going to find all the certain digits. We can see that this is the bottom of the meniscus here is above the 50. So we know that the 5 here is certain. And then we can see that it's 1, 2. So the 2 is certain, but we're going to estimate this last place. So we know that the certain digits are 52 milliliters, but I think that this is closer to the 3 than to the 2. So I know it's more than 52 and a half. I'm going to estimate that it's 52.8. There we go. We're estimating that uncertain digit. It's about 8/10 of the way. So I'm going to estimate it at 52.8 milliliters. We'll talk about certain digits or significant digits tomorrow, but for now and for the rest of the year, please remember that whatever the graduations are, we're always going to estimate 1 digit and only 1 digit past the graduations, whether we're measuring volume, length, or mass. So I'm going to have you guys observe this meniscus. If you need to pause the video now, I want you to determine what volume of liquid you think is in this graduated cylinder. Okay, so we've talked about volume. Let's talk about measuring mass. So we'll usually use a digital balance in this class. We will occasionally use the triple beam balances, but measuring mass is pretty simple. The digital balance estimates the final digit for you. I know that it's going to give you a readout, and you're going to think that all of those digits are certain, but I promise you that that final digit is an estimated number. in order to measure mass properly, there are some rules we need to follow with the balance. We want to always check to make sure that our balance is level and zeroed out before we use it. There's a little bubble level on the balance, and you can adjust the feet to make sure it's level. Now we're going to push the button that says 0 to zero it out. We're never going to weigh directly on the balance pan. We're always going to use either a weighing boat or a piece of weighing paper to protect the pan. We're not going to weigh hot or cold objects. It interferes with the electronics as well as actually interfering with the way that it measures mass. And if there are any spills, we're going to clean those up immediately. Okay, so that's our conversation on units and measurement. As always, please make sure you write down any questions and we'll talk about them in class. Look forward to seeing you soon.